Hi guys, I'm going to go ahead and go over our review for today that we did in class in preparation for our test tomorrow. This review is going to cover every problem in the packet. There is a video going over the ones that we missed in class or that we did not do in class, so if you wanted to go back and check your work on those. These are some of the notes that I suggested that you put on your yellow work paper for tomorrow, your yellow note sheet for tomorrow. And then you can add any other notes that you might find important, okay? All right, so let's go ahead and get started with this. Again, I'm going to be working on every problem in this packet, so if there was something that you missed in class, you can go ahead and go straight to that one. For number 1 and 2, we are simplifying expressions and combining like terms, okay? Remember that word expression means that there is no equal sign, all right? So to simplify, first thing we want to do is we want to see if we can combine what's inside the parentheses, which we cannot because one has an x, it's a variable term, and the other one does not have an x, so those cannot be combined. So for distribution in that case, we're going to go ahead and distribute what's on the outside to be multiplied to everything on the inside. Negative 5x times 2x gives me negative 10x squared. Negative 5x times negative 1 gives me positive 5x. Then I have negative x and negative 4x squared. Okay, so once we've done distribution, now we're going to go back to see if we can combine like terms. Well, I always start with the one with the highest variable first. Highest degree. A degree is also, highest exponent first. Degree is also that exponent. So those two there will give me negative 14x squared. Then I can combine the ones that have just an x, which is positive 5x minus x. And that gives me a positive 4x. Okay? So my solution, negative 14x squared plus 4x. Okay? All right, so let's go on to number 2. On number 2, there is no distribution. So on this one, we are just looking at combining like terms. So I have 12c and negative 2c. The sign goes with that coefficient or with that term. So 12c minus 2c gives me 10c. Negative 3 was no variable, so it's a constant with negative 13. Those two combined will be negative 16. Okay. All right, and now we're going to go to number 3. On number 3, we are going to solve this equation. So it's an equation for me that helps me just to remember that whatever I do to one side, I do to the other side. Okay. I look to the left side and see if there's anything that I can combine. Well, there's nothing on the left side that I can combine because they are not like terms. And on the right side, I cannot combine those either. So my next step is look to see if I can get all the variables to one side. Okay. So I have 4x on the left side and negative 10x on the right side. I'm going to choose to move the smaller one of the two, and that is because it'll keep me from having to divide by a negative. However, I can move over the 4x, but in this case, like I said, I'm just going to move over the smallest x term. So instead of having negative 10x on the right side, I'm going to get rid of that, and I'm going to add 10x on the left side. So that gives me 14x minus 2 is equal to 18. Now I've got all my variables to one side, so let's get all the constants to the other side. So instead of subtracting 2 on the left side, I'm going to add 2 on the right side. So I've got 14x equals 20. Okay. 14 and x are being multiplied. Even if it had a negative in front, they would still be being multiplied, okay? So the inverse of multiplying would be dividing. So instead of multiplying on the left side, I'm going to divide on the right side. So I get x equals 10 over 7. Okay? So x equals 10 over 7. All right, now let's go on to problem number 4. Okay, so here in problem number 4, again, I'm going to look at the left side to see if there's anything that I can combine. Well, on the left side, I can combine 2x and negative 4x. That gives me 5 minus 2x. On the right side, there isn't anything I can combine, but I can distribute. Okay. So then I'm going to have 3 minus 3x. Okay. So now in this case, I said that I want to get all my x's to one side. And I typically move the smaller x value. In this case, it would be negative 3x, which is smaller than negative 2x. But just to show you what would happen if I did it the other way, let's go ahead and take negative 2x and move it to the right side. So if I was to, instead of subtracting 2x on the left side, I'm going to add 2x on the right side. So then I've got 5 is equal to 3. Negative 3 plus 2 is negative x. Now, instead of adding 3 on the right side, I'm going to subtract 3 on the left side. So then I have 2 equals negative x. Now remember that negative there is with the x, okay? And it is actually like a negative 1 in front of the x. That's what it actually is. It's negative 1 times x. So x isn't by itself yet. It's still being multiplied by negative 1. So what I have to see is I actually have to divide off negative 1. So 2 divided by negative 1 is negative 2, which is equal to, the negatives make it a positive. So my answer is x equals negative 2. So just to point out, had originally I took the negative 3x and moved it to the left side, my answer would have still came out the same. Okay. The only thing is I wouldn't have had to complete this last step right here in the order that I did. Okay. All right. So now we're going to go on to number 5. Number 5, solving a literal equation. Okay. So we've talked about these literal equations pretty well in class. So it's just like solving for a variable x, but this time we're solving for a different variable. Okay, we're trying to get t by itself. So what's happening between the r and the t? Well, they're being multiplied. Well, what's happening between the p and the r and the t? Well, they're being multiplied too. So the p and the r are really being multiplied times the t. So instead of multiplying by p and r, what I want to do is the inverse on the opposite side of the equation. So I'm not going to multiply by p and r. I'm actually going to divide by p and r on the left side. So my answer is going to be t equals I over p times r. Okay. All right, number 6. Solve for x. Okay, so we can do that. All right, first thing, I'm trying to get the x term by itself. So this term here has x in it. Remember, terms are pieces that are added or subtracted together. So I don't need this term. However, I can't just say, hey, it's gone. I've got to move it to the other side of the equation. So I'm going to have y minus b is equal to mx. Now I'm still trying to get x by itself. So how do I get rid of that m? Well, I don't want it on the right side, and it's being multiplied on the right side. So instead, I'm going to divide it on the left side. Okay, so we are going to have y minus b over a common denominator of m is equal to x. So in class today, though, somebody asked me, I could leave it as y minus b over m, but couldn't we also leave it as y over m minus b over m? And yes, that is true. We could leave it that way as well. Either one is correct, okay? So it's just that these two here have a common denominator, which is represented right there, okay? All right, so now let's go on to the next problem is number 7. Finding the average rate of change, or finding the average slope from when t equals 50 seconds to when t equals 70 seconds. Okay. Now in class we didn't refer much to t, we always referred to it as x. So we would have said x equals 50. Maybe I should get the right size pencil here. We could say x equals 50 or x equals 70. That's still the wrong size tip. Okay. X equals 50, that's better. Or x equals 70. Okay. And I know that t represents x because t is talking about seconds. When I look at my graph, time in seconds is where we would normally see the x-axis. However, they're not calling it x, they're calling it the t. Okay, so they want to know from 50 seconds to 70 seconds, what is the average rate of change? Well, 50 seconds, okay, when 50 seconds is our x or our t value, what is our y value? Well, that would be 100. Okay. Remember, that's an x value and a y value. And since it's our first ordered pair, it's x1, y1. Okay. Our second ordered pair would be at 70. So that would be 70, 40. And that would be x2, y2. Okay. And we're only looking for the slope between these two values here. Right? So we're not looking for everything else, just the slope between those two there, which I just highlighted. All right, so with that one, if we're using the slope formula, it is the change in y over the change in x, or y2 minus y1 over x2 minus x1. Okay. So our y2 value is going to be 40 minus 100 over 70 minus 50, which brings us to negative 60 over 20. Now that negative 60 over 20 can be reduced. Okay, 60 can be divided by 20 3 times. So then our slope on that one would be negative 3. Okay. Negative 3 over 1 would be one way of writing it, or just negative 3. Okay. Now, I also want to show you a different way to find slope, which some of you might have seen, but most of you today in class saw the actual change in y over change in x formula. So let me erase some of this stuff. I'm going to erase everything on the graph. All right, so we said from 50 to 70. Let me pick a different color here. Okay, so from 50 to 70, and we're still looking for that slope there. Okay. So from 50 to 70, I want to know how many I went down from there to there. Even though we think it's one box, when we look here, we can see from 100 to 80 is actually going down 20. Well, if I go down another box, that's going down another 20. Again, that would be a negative 20. So our rise on this one is negative 60. Negative 20 with negative 20 and negative 20 combines to negative 60. Now, for the run from 50 to 60, that's positive 10. And from 60 to 70, that's positive 10. So that gives me 20. Okay? So either way, when you're looking at it, these slopes, they come out the same. Okay? It is just what do you see when you're working out this problem, and that's the method that you should use. Okay? All right, for number 8. First thing we have to do with this one is we have to get it into slope-intercept form, okay? So we have to get y by itself. So I'm going to take the 4x away from the left side, and I'm going to move it to the right side. Okay? Then what I want to do is I don't want to multiply negative 2 to the y. So instead I'm going to divide the whole right side by negative 2. So then I have y equals negative divided by a negative is a positive. 4 divided by 2 is 2x. And negative divided by a negative is a positive. 8 divided by 2 is 4. All right, now that I have it in slope-intercept form, I can identify the slope and I can identify the y-intercept. Okay. That y-intercept is the b value. Okay. So my slope is, currently it's just 2, but since I like it a fraction, I'm going to put 2 over 1. And my y-intercept is 0, comma, 4. So it's going to go up 2, right 1, and it's going to start at 4. All right, so on the graph, let's start at positive 4 and go up 2, right 1. And remember, if we cannot go up 2, right 1, then instead we can go down 2, left 1. Down 2, left 1. Okay. The goal is when we will go to check our work, is that when we draw our line, our linear graph, that it goes directly through all points. And remember to include an arrow at the end of each of these linear graphs, because for us, it is not told that there's a stopping point. It goes on forever and ever. All right, the domain is the x values. The range is the y values. So when I'm looking at this, I want to see how far to the left it goes. So to go to the left, it goes on, it would keep going to the left the further down it goes. It's getting further and further to the left. So the domain is negative infinity. And how far to the right will it go if it keeps expanding? It will go on to positive infinity. Okay. Now for the range we always start at the bottom and look up. So how far down on the y-axis did this graph go? Well, it went down forever and ever. The smallest number is negative infinity. Okay. On the right side, it was increasing. So how high does it increase? To positive infinity. Oops, that looks like an F there. positive infinity. Okay. The x-intercepts on this one, where does it cross the x-axis? So it crosses the x-axis where x is -2. And at that point, the y is 0. And then it says, where is the y-intercept? Well, the y-intercept, it crosses the y-axis where y is 4, but the x value is 0. All right? All right, I'm going to come back to number 9 in just a few minutes. I want to finish up with that one. But for right now, I'm going to jump down to number 10. Okay? All right, number 10, graphing a linear inequality. Excuse me. So, first thing, we want to get this into slope-intercept form, similar to y equals mx plus b. Okay? Treat the inequality similar to what you would treat an equal sign to when we're solving for it. We're trying to get y by itself. Only different is if we're multiplying or dividing by a negative number, we would have to flip over or reverse the inequality. Well, this one, y is already by itself, so there is no simplifying that needs to be done or any inverse operations because y is already by itself. So on this one, our slope is -2. If I want to make that a fraction, I put it over 1. And our y-intercept is 0, 4. Okay, that's that b value. So when we graph this, we start at +4. And we're going to go down to right 1. Down 2, right 1. Okay. Now, when it is greater than or equal to or less than or equal to, that's a solid line. Okay. When it's just greater than or equal to, then that is a dashed line. Okay. So let's go ahead and draw that line. I can kind of cheat here, but not really. Okay, let's try that again. Okay. And then remember to put an arrow at both ends. Okay. So if we're saying y is greater than or equal to, it's going to be a solid line. And then this is where we have y is greater than or equal to our line, the line that we graphed. Okay. So if y is greater than, that means it's any value that's above the line. So we would shade everything above the line. Okay? All right, last problem that I said we were going to talk about is problem number 9. Okay. So problem number 9 here, I have given you guys a table, but if you're at home, you won't have this table. So what I want to do is I want to draw an x and a y axis. Okay, actually I'm going to move that because I'm going to probably need this room to do some work. So I'm going to put this x and y table, I should say, x and y table right down here. X value and y value. Whenever I start building a table, if I'm not sure which values to use, I will always use -2, 1, -2, -1, 0, 1, 2. Okay. So I always start with 0, -1, -2, 1, and 2. Now on your table, you actually have another spot, which is 3. So go ahead and put that value in as well. All right, so what we're going to do is use substitution. So we're going to backtrack to what we did originally. We're going to take -2 and we're going to substitute it in for x into that equation. Okay. Now I also want you to pay attention to that today we're dealing with absolute value bars. Right? Absolute value is always going to come out a positive number because it's always thinking about how far away from the value 0 is it. All right, so let's start this. Let's first rewrite it with -2. So I've got y is equal to the absolute value of -2 minus 1, close absolute value, minus 3. So that gives me y equals negative 2 minus 1 is negative 3, absolute value of negative 3. Now the absolute value of negative 3 is 3. Okay, it always comes out as a positive number. So I have 3 minus 3. So when we substituted in negative 2 into the equation, our answer comes out to be y equals 0. So on our table for negative 2, I'm going to put in 0 for y. Okay, let's do it again. This time we're going to put in negative 1. So we have y equals absolute value. Negative 1 is what I'm taking from the table. Okay, so I'm taking the negative 1 and I'm substituting it in. Minus 1, close up that absolute value, minus 3. So y equals negative 2 minus 3. Y equals 2 minus 3, so that y equals negative 1. All right, let's do one more. So we have y equals the absolute value of 0 minus 1, minus 3 on the outside. So y equals, well, 0 minus 1 is negative 1. The absolute value of that is 1. So y equals negative 2. All right, I'm going to let you finish those last 3 for the table part. I would love to see the work for those. Okay, but I'm going to give you what those answers are so you can check them. But I still want you to do the work where you're actually substituting it in. So let's see, if I plug in 1, my value would be negative 3. If I plug in 2, if I substitute in 2, I'd get negative 2. And if I substituted in 3, I would get negative 1 for my output. I'm going to graph these 6 values. So negative 2, 0. Negative 1, negative 1. 0, negative 2. 1, negative 3. 2, negative 2, and 3, negative 1. Okay. Now, if you notice, this one here doesn't make one linear graph. Okay. It looks like this is our lowest point, and from here, it actually started somewhere way over here, and it dropped down to that point there. But at that point, it was no longer going down, so I can't even draw a down arrow over there. It stops right there. It stops decreasing, and then it actually starts increasing again. Okay, and if I kept doing numbers like 4 and stuff, I would see that it's just going to keep increasing forever and ever. Okay, so when I'm looking at the domain of that graph, oh, first the vertex. The vertex is that turning point. So what is the vertex? What is the value of that? Well, the vertex is going to be at 1 and negative 3. So the vertex is at 1, negative 3. The domain are the x values. So how far to the left is this graph going to keep going? Well, to the left, it's going to keep going forever and ever and ever. So that left side is going to be negative infinity. How far to the right is it going to keep going? Well, it's going to keep going to the right forever and ever. So that's positive infinity. Okay. Now, the range is the one that's going to be tricky because we always got to start at the bottom. How low does this graph go? Well, it stops right here. And that value is negative 3. So it started at negative 3. And then right there it stopped. Hit like a brick wall. Okay. So it can't go any further than that. It stops right there. Then how far up is it going to go though? Well, as it's going up, continues up, up, up. that's actually going to be positive infinity because those arrows tell me it's going to go on forever and ever and ever. Well, there's always going to be another number, so they're pushing the limit just a little bit more each time. Okay, so -3 plus or 2 positive infinity. All right, I am going to end this video here. This is the entire worksheet that we studied for today. And then on this one, remember, just send me a reminder if you have any questions on any of this, okay? And that we do have that summative in class tomorrow. So make sure that you are well rested and ready for that, and have your notes page, and that you included any kind of notes that you feel necessary to that. All right, guys, have a great night.